In this video, I'm going to talk about how to graph our hyperbola functions. Hyperbola is a inversely varying function. What it means is, as you can see, the x is in the denominator on the other side of the equation and the y is in the numerator. Meaning, if x value increases, 1 divided by a very large number makes the y decreasing. So, for example, the best examples that we can talk about is if you want to get a work done in a certain amount of time, right? Let's see the scenario. If you hire more people, will you take less time to finish the job or more? Obviously less, correct? So as you increase one quantity, the other quantity decreases, and that is where these hyperbola functions come into picture. So the basic skill that you need to understand is, if they ask you to graph it, you need to know two important features. This has two separate branches because it's not possible to draw or connect all the points without lifting your pen. So that's why this is like a discontinuous graph. So that's why it has two different pieces and two different curves. So this is what we are going to do right now. So when x is -3, 1 divided by 3, that's -1/3. This is going to be -1/2. This is going to be -1. And then if you have negative half substituted into the equation, you'll end up with -2. Now watch this. When x is 0, 1 divided by 0 is infinity. So we just simply say undefined, okay? When you substitute half, the answer is 2. When x is 1, this is 1. When x is 2, you get half. This is 1/3. So now basically you're going to go and plot those points. So when x is -3, it's -1/3. So when x is -1/3 is some, I'll change the color, one second. Okay, -1/3 is right there. When x is -2, it's -1/2. So -1/2 will be somewhere there. When it's -1, so you get -1, fine. When it is when it is 0, it's not defined, so we can't pass through 0. When it is half, it is 2. Half makes it come to 2. Then you have 1 to 1, and 2 is at half, and 3 is at 1/3, somewhere there. And so you can see that when it is when x is -1, we got -1. When x is -1/2, oh, there it is, -2 right here. So if you there's no way that you can connect these points, so that's why we see that this is something like this. I'll connect it properly. So this is how it has two different curves and two different pieces. All right, so that's all is graphing. Now let's talk about asymptotes. Especially for hyperbolas, you have a horizontal asymptote and a vertical asymptote. The reason being, you see, these curves are not able to pass beyond these barriers. So this whole thing is your horizontal asymptote, and this is your vertical asymptote. That's all you need to know for hyperbola graphing functions. I hope this video is helpful. Again, I repeat, I substituted into my calculator, okay, whatever x values they're asking you to substitute into the original equation. In your case, this is the original equation. We substituted the x values and we got the y values. Once your table is done, you take these points and you plot them on your graph. And we clearly saw there's no way that I can crisscross these points and connect them. That's why I'm making two discontinuous pieces, but together we describe that as one equation, which is our y equals 1/x. So that's all. All right, guys, and we watched We looked at their asymptotes, and both x-axis and y-axis are acting as their asymptotes. So if someone asks you what is the equation of the line of the horizontal asymptote, it's nothing but x-axis, so that's y equal to 0. Vertical asymptote is y-axis, so x equals to 0. As long as you know this much information in your year 10, this is more than enough. All right, guys, thanks for watching.